those safety specifications are known, right? Those standards are there. So we basically use those standards to build our monitoring approach, right? So those are known a priori because the heart rhythm in terms of ECG, that is a standard that is there, right? We use that to detect, to monitor ECG and to detect abnormalities, right? But then when we want to apply this similar technique, for example, to other kind of medical systems, right? How many of you know what an insulin infusion system is? What is it used for? What is an insulin infusion system? What it's used to treat what? So pacemakers are used to treat arrhythmias, right? The cardiac abnormal. What is an insulin infusion system used for? Diabetes, right? So whenever a person is suffering from this high low blood glucose, right, the diabetes, right, so the insulin has to be induced at appropriate times, right? So there are insulin infusion systems that actually monitor the person blood glucose levels and that induce insulin at appropriate times, right? So such kind of systems are also existing, right? So similar to like, so I am not going into details step by step, but then of course similar to these pacemakers, right? Even the insulin infusion, if we see the functioning of an insulin infusion system, it is also like connected with, it also like is connected with different kind of components through the wireless access networks and so on, right? So even these kind of systems are also prone to security issues, right? Even hackers could also hack these, and then that hack or the change can actually lead to giving more insulin dose that could harm the person, right? Or not giving the appropriate insulin dose that can also harm the person, right? So these things were indeed reported, those things are possible, right? So how could we actually detect this? By again monitoring other parameters of a person non-invasively, in the sense without communicating with the insulin pump, how can I detect these abnormalities, right? Again we must rely on measuring other parameters of the person, right? What are the other parameters of the person? Of course the other, what could we actually looked at measuring ECGs, right? ECGs and PPG of a person, right, through sensors. So with respect to heart abnormalities and ECG, the specification is clear, right? What is the safe functioning of the heart, that is known, right? But then once we look at if our input for monitoring is again an ECG, right? So ECG versus blood glucose, the relation is not that clear, right? We are taking ECG as input, but from the ECG input I want to detect whether the blood glucose is high, low, these kind of things, right? So there we don't really have a clear correlation, right? ECG traces the duration of the peaks in the ECG versus blood glucose levels. So there is no clear correlation, right? So how will machine learning, how did we actually use machine learning data analytics here? So in this case, in order to like monitor these blood glucose levels, I need the policies or I need the specification in terms of ECG, because that is the input that I am relying on, right? So in order to learn the policies of detecting low blood glucose, high blood glucose and so on, we have basically made use of this data analytics statistical framework in order to find the correlation between the peaks of the ECG versus high blood glucose levels, right? So we have applied, we have used different data sets, we have applied the data analytics techniques to actually infer the relation between the ECGs versus blood glucose, which is not trivial, right? Is it trivial? ECG versus blood glucose is not trivial, right? But once we have vast data available, if I have data available of a person's ECG versus the blood glucose value at different times, we could apply these inference techniques, right? Data analytics ML techniques to make that correlation of this blood glucose with the patterns in the ECG, right? So that correlation is made, and then the policies are actually framed in terms of ECG, right? What do I have as input continuously? I keep on measuring ECG. From that I want to detect whether the blood glucose is high or low, right? So these kind of things are indeed possible, right? And to mention about a couple of other things. So So what is hypertension? Blood pressure, right? So blood pressure is also called as hypertension, right? So we have also noticed that, okay, the pattern of the ECG, the duration between different peaks in the ECG also has some relation with the blood pressure, right? But then this is not trivial. We cannot just examine one sample and say this. There should be analysis done over a vast data sets, right? So as we all know, like, okay, blood pressure is one of the common causes for other kind of abnormalities, right? If we are able to continuously monitor BP of a person and give alerts at the appropriate times, it is much beneficial, right? It is highly beneficial because BP can lead to other kind of cardiac risks and other things, right? So what we have actually proposed, we have proposed like a monitoring solution that will continuously sense ECG and that will also indicate the BP, whether person is like prone to high BP or other kind of things, right? So these are indeed possible. We were able to do this by applying this kind of machine learning techniques, right? The data analytic machine learning techniques, right? So in order to infer the relations between ECG intervals versus BP, of course we have taken large data sets, we have done the analysis using different machine learning techniques, right? Like decision trees and so on. From that we have inferred the BP related policies in terms of ECG, right? And using which we have designed our solution, right? Okay, so these are like a few examples. So one more example is related to, how many of you are aware of what minimally invasive surgery is? What is a minimally invasive surgery? We all know about open surgeries, right? We all know about open surgeries where the doctors actually cut open and then they do the process, right? So what are the challenges with open surgeries? Of course, they might have more recovery time, right? Since they cut open and do the process, the recovery time is more, right? So nowadays, the minimally invasive surgeries are gaining importance. What is a minimally invasive surgery? When we talk about these minimally invasive surgeries, instead of cutting open, they basically do a small insertion, right? They basically, through a small insertion, through a small hole, they insert a miniature camera of, very, tiny micro camera is inserted through a small hole, right? And they insert the instruments through small holes, so this will avoid cutting open to do the procedure, right? So what do the doctors basically do? Through a small hole, they insert the miniature camera, which will show the doctors will be given a view of what is there inside on a screen, right? They basically observe what is there inside on a screen and they insert the appropriate tool through the small hole to carry out the procedure, right? So do you think what is easy for a medical practitioner? Is an open surgery easy or this minimally invasive surgery easy? What is easy for a doctor? Open surgery, right? Obviously open surgery, for a doctor to perform a surgical process, open surgery is easy because they will cut open, they can see everything clearly, right? They can see everything clearly, they can judge how to do the process. It's much more easy for a doctor. Whereas minimally invasive surgery is more attractive for a patient, from a patient perspective, because they don't have to be like, the recovery time will be much faster, right? Because it's not an open surgery where they cut open and then do the stitches, right? So minimally invasive surgeries are quite challenging for doctors because they don't have a proper vision like a proper open surgery, right? And they will not be also able to judge the pressure that they are applying through some tool, because they are inserting a tool through some small hole that is made, and then they are trying to do the procedure, right? So the pressure they apply, all these things, there are a lot of challenges involved, right? So using this AI ML techniques and using other kind of approaches, if we are able to build some sort of assistive framework, right? It's a sort of automated assistant for doctors for performing these minimally invasive surgeries, it will be quite useful, attractive, right? So in that direction, we have started to work on an approach where we basically propose this sort of a framework, right? So here we combine sort of a learning approach followed by our policy-based monitoring approach to provide a sort of an assist, right, automated assist for surgeons, right, for performing this minimally invasive surgeries. So what is the AI-based module doing here? So when a miniature camera is inserted, what does the camera give as outcome? What is the output of a camera? Is a video, right? Is a series of images which is a video, right? So the initial module that is lying here, which is an AI-based module, its responsibility is to analyze the video frame by frame, image by image, and it should detect what are the surgical tools present in that frame, right? What is the depth of the tool and so on, right? It should automatically analyze the frame quickly, and it should give that as an outcome, right? So at time instant 1, of course, these tools are present, right? And the depth of this tool is so and so, right? So once those are automatically done by the tooling, so we may have some clear clinical guidelines, right? For doing the surgical process, the clinical guidelines might say that, okay, after inserting so and so tool, something should not be present for so long, for example, right? So these clinical guidelines can be assessed automatically when doing the surgical process, right? How will it help the surgeons? So when the surgeon, when doing the process, unknowingly, of course, they will not be able to judge, right? Because they do not have the complete vision. They are not cutting open. So unknowingly, if they insert the tool to more depth or so on, an alert can be raised, right? The framework can actually raise an alert to prevent something bad from happening, right? So that the surgeon can take preventive measures, right? So here we use a combination of this AI-based approach together with other policy-based frameworks we have to build a solution, right? To build this automatic surgical assistance framework, right? Yeah, so there are other details, but there are a few other things that we work on, but then I think I will skip this for now, right? So I think in summary, I think we mainly spend more time on understanding the basics of AI, right? How this evolved. I gave a few simple examples. So that is where we spent more time on. And then of course we skipped this. I quickly mentioned about some of the applications we are working on, right? So I think with this, what I wanted to convey is that, okay, whatever domain you are working on, you cannot go away with applying these techniques, right? You should learn these AI machine learning techniques. You should be applying in different domains. I'm sure you will have all the required resources, right? Utilize those resources. I hope you will all come up with novel applications using these techniques, right? So now the techniques have evolved. Now it's basically you all who should apply the techniques to come up with novel applications, right? That will be useful for the community. How many of you are towards building novel applications using these techniques? So I mentioned various areas, right? Also within India, we are looking at different areas, right, to apply these techniques, right? How many of you are eager in working on different domains? Raise your hand. So I want more hands to be raised. Raise your hand. How many of you are eager? Okay, how many of you understood something from this talk? Of course, we didn't discuss about the techniques you will learn. I'm sure your teachers here will be teaching about different techniques. Okay, good. So we can stop here. If there are any questions, feel free to ask. Okay. I know you all are hungry now, but if there are any quick questions, you can ask. So then I will come again later to see what you have built, right? I will come again later to see what you are working on, what you have built, right? Okay, all the best, and I hope to see you again, okay? I will come back again to interact with you at some point.
process so much of time.
No.
I hope you all enjoyed the session. इस पूरे AI सेशन के बाद कहीं तुम लोग मुझे एलेक्सा, सिरी या बिक्स भी मत समझ लेना. I am still a human. My heart fills with a lot of gratitude and respect for our distinguished speaker for not only sparing his invaluable time for us to grace this occasion, but also for enlightening us with his commendable talk on the subject. So we thank you, sir, for your invaluable time. May I now request Director, sir, to present a token of appreciation to the guest.
Thank you so much.
Yeah, okay, thank you. Yeah, please. May I now invite Director, sir, to propose the vote of thanks.
So respected the professor, Dr. P. Srinivas from IIT Bhubaneswar. Even though he is very busy in his regular schedule, but taken out the time and he is given consent to visit our institution to deliver the today's lecture. So actually today he has the class up to 9:30. He has taken the class and then immediately he rushed to our college to deliver this lecture. So from this particular point, what we have to learn from these things, we should be sincere to our work. Once you are sincere, then everything is possible and you can grow in your life. So that message sir has given to all of us, and at the same time, as already I have informed regarding these are all students from first year, and at that time itself sir told that I am going to cover basically the important areas in the AI and ML and as well as the data science. I am not going into the depth of the subject and only regarding the applications. So overall, I hope that every one of you now understood the importance of the AI/ML techniques and data science techniques in the entire the field of not only engineering, in the field of science and field of society, everywhere we are using nowadays the AI/ML techniques. It is not only restricted to the computer science students now. Any branch of engineering, any science, even including the MBA people. Now recently we have revised the MBA curriculum for the 2024. We have introduced all the AI techniques, artificial intelligence, everything we have included in their syllabus. So that means irrespective of your study, every one of you should have a strong concepts in this AML and data science. It will be helpful and the future is with these two techniques. Okay. So I hope that all of you have learned certain things from this particular lecture, and at the same time, I would like to thank all the organizers and supporters for this particular program and those who are involved in this program directly or indirectly. So I would like to thank all of them. And finally, anyhow, I would like to thank all the students. Very patiently you have listened the entire session. So definitely I know that it is not that easy to sit for 2 hours and to assimilate the things from the lecture. But at the same time, every one of you sincerely tried to learn something from this lecture, and you have noted down certain important things. And tomorrow, whenever you go for the actual study, then all these particular concepts will be useful, and you will have a basic idea how I can implement practically these particular concepts. Otherwise, it will become a theory only. So now theory to practical, how to implement it, you can learn from these particular examples. So thank you one and all, and thank you. So those who are interested, you can come for the photo session. Quick, quick.
Students, interested students are requested to come and capture their memories. Don't think AI will take a photo of you, you'll be sitting there. You have to come over here. Atra, tatra, sarvatra, everywhere AI is there. But still, you have to also work harder. Anyways, thank you. You have a next session at 2 o'clock. Be here by 1:45. Thank you. Thank you, sir.